This tutorial will focus on using the Android Roam library. I will be demonstrating how to use Roam to perform CRUD operations on an Android apps local database. CRUD is an acronym for Create, Update, Retrieve, and Delete. A little background on Roam. Roam is a persistence library from Android Jetpack, which provides an abstraction layer over SQLite to allow for more robust database access while harnessing the full power of SQLite. As a database object mapping library, it makes it easy for developers to access database on Android applications. Roam provides convenient APIs to enable apps query the database and verify source queries at compile time. This allows access to the full power of SQLite while having the type safety provided by Java SQL query builders. Components of Roam. There are three components of Roam, which are database, entity, data access object, also known as DAO. Database is an abstract class that extends Roam database and is annotated with database, contains the database holder, and serves as the main access point for the underlying connection to the app's persisted relational data. The entity represents a table within the database. The data access object contains the method used for accessing the database. About our app. The app we will be using for demonstration would be called Learn, which will be used to manage a list of students. The following entity relationship diagram illustrates how the SQLite database will be structured. In this diagram, we have a student table which has three fields: ID of type long, which will be the primary key, full name of type test, and email of type test. The database, which will be called Learn, would have one entity or table named students to store the registered students. The sample app will show us how to add, edit, and delete student entries. To illustrate how Roam can be implemented, I have included versions of the project source code for this tutorial on GitHub. The two directories before and after are versions of the project source code. Before contains the state of the project before the implementation of Roam, while after contains the state of the project after the implementation of Roam. We'll be working with the project from the before directory. Now, to follow up with this tutorial, you should have an understanding of live data and view model from the Android additional components, because this is what we're using in this project. Now let's go through the source code for this tutorial. We have a student model class which represents the entity for the database. It has three fields: ID, full name, and email. ID represents the primary key. Also, we have a data source class which is called student data source. This data source has methods to list students, get students, add students to the database. The statements to add students will be run on a background thread. Then we have update students. Update students will also be run on the background thread. Then to delete students, statements to delete students will run on the background thread. They also have a view model class which has methods to get students, the provided ID, and get list of students. Then also we have student adapter and a view holder which will be used by recycler view. Student activity displays a student entry. Student edit activity would create and edit student entries. Student activity would list the students in the database. Then we have the Roam package directory, which we have files for Roam, like the our database and our DAO file. I've also included 20 to-do lists to guide us towards implementing Roam. Now let's run the app to see how it is. Now this is the app before Roam has been implemented. We've used students. Currently there are new students. We try to add students. We save. No student available. This is because the database has not been implemented in this app, and that is the reason for this tutorial. Now, going to the to-do 1, requires to add room runtime library dependencies. I will comment this line because that's where it is. To the 2, add room compiler library dependencies. I will uncomment this because that's where it is. Also note that at the time of this recording, the stable version of room library for Android Jetpack is version 2.0. So I'll sync the project. Into the 3, we have to convert this class to a room entity. Now, an entity in room is a class annotated with the entity annotation. The table name in this case is student. Then to the 4 requires us to make this field a primary key. We use the primary key annotation to do that. To the 5 requires us to make this field a text field, and the table name, full name, we use column info. We give a time affinity, which is the type text, and the name, full name. To the 6 requires us to make this email field a text field. So using the column info and the type affinity of text. Now we go to the 7. The 7 says we should create a DAO named student DAO in the room package. Now a DAO in room is either an abstract class or an interface annotated with DAO. But in this case, we're using an interface. Into the 8, we have to add methods to insert, update, and delete students in our DAO. So we annotate it with the insert annotation. And when there's a conflict, we replace the existing data with a new one. This method takes a list of students and returns the list of their primary keys. This method updates the table with the student provided and returns the total number of affected rows. Now an update is annotated with the update annotation, and when there's a conflict, we replace. For delete, it deletes the students from the table and returns the number of affected rows, which is annotated also with delete. Into the 8, we have to add methods to get students and return a live data for a specific student. To do that, in the student ID, we annotate this with a query annotation. And supply the query to run. So what this does is it selects the student from the table with the ID that matches the provided ID. Into the 10, we have to add get students to return a live data of list of students. Now I'm ready to the query to run. So what this does is it selects all the students from the table and return the live data of the student list. Into the 11, to create a database class called database and database name learn in the room package. So database in room is an abstract class that extends room database annotated with database. Then we send the list of entities. In this case, we only have students. So the version of the database, version 1, export schema. We are not exporting the schema, so we use false. Also note that a database is one of the three components of ROM along with entities and DAO. The next step is to create static methods to access the database. So to initialize the database, we call the ROM builder method, provide the application context, database class, and the database name, in this case, len, then we build. So this is for the database class. Then we have to add abstract method student DAO to the database class. So this method gives the application access to the student DAO class. In 2014, we are to declare a field variable of type student DAO in our student data source class. Then we initialize the field variable. From our database, we get the database instance, application context, then we get the student DAO. In 2016, we are to return the result from calling getStudent methods from the student DAO class. This method gets the student with the associated ID from the table. We have to get the list of students from the student DAO class. Then in 2018, we have to assign the value of calling insert method from student DAO to item IDs. We provide the list of students to insert. In 2019, we have to assign the result of calling update method from the student DAO to total updated. While in 2020, we have to assign the method of calling the delete method from student DAO, providing the list of students. Now, if you notice, the delete students, update students, and insert students, we are calling these methods from the background. So this is because Android restricts us updating, inserting, and deleting database from the main thread. So this is from the insert. You notice that mDAO.insert is run from the student DAO. So the body of this class will be generated by ROM. So what this does is it inserts this table and returns the IDs of the record inserted. Then this is the delete, and this is getStudent, and this, which are the methods we are using in our student source. So this completes the steps to utilize ROM in an Android application. Now let's run the app. So running the app, we notice here that we can click view students. Currently there is no student, so we add a student. We add another entry. We add another entry. We can edit. We can delete. We can delete. We can delete. This completes the tutorial on how to use ROM in an Android application. Source code for this tutorial will be available on GitHub. Thanks for watching.